So the basic operation then is going to be that we have a job statement which serves to identify the particular unit of work. Then we have an execute statement that identifies the program that is going to be run. And then we have a DD, or a data definition statement, which identifies the individual I/O resources that are going to be required for that particular program. All input files and all expected output files will be identified using the DD statement. The parameters themselves consist of positional parameters and keyword parameters. A positional parameter must be specified in a required order. And in other words, what that means is that each position has a specific value. And so if that value is not going to be coded, a comma must be coded to indicate its absence. In the case of the keyword parameters can be located anywhere on the JCL statement, and they are identified by having an equal sign. So there will be a keyword and an equal sign and then the value. So these keyword parameters then are going to be separated by commas, and they do not have any specific order in which they can occur on the JCL statement. They are, of course, subject to the syntax rules that we've just mentioned, but the point being is that keyword parameters can be coded in any order on the JCL statement. So for our first demonstration, what we'd like to take a look at is to show both how we can perform a standard function using the IEBGener utility program as our JCL and our batch process. And what we are going to do is copy an input file to an output file. First, we will demonstrate using our regular ISPF 3.3 copy function, which will illustrate how we would perform this action using our regular TSO session. And then we'll illustrate how we can use JCL to perform the same action using a batch background job in order to copy the data between these two files. So the point is to illustrate that these are identical actions that are being performed. One is being done in real time by a user, the other would be done using JCL as an unattended job that is running without intervention. Now in this particular example, we're going to first take a look at how we can copy the data from this file here called old.dataset, and we're going to copy it into one that we call new.dataset. So you can see the 11 records that we have here, and so what we can do now is under ISPF, we'll go to option 3.3, and in this case we're indicating that we want to copy this. So we're going to copy old.dataset, and we're going to copy it to one that we call new.dataset. Here's our prompt indicating to allocate this dataset, and so we do that, and we can see in the upper right hand corner the fact that the dataset has been copied. So now if we wanted to go take a look at this dataset, we can go and look at the new file that we've created, and in this case when we take a look at it, you can see that we have the 11 records in there using the ISPF copy. Now let's do the same thing, for example, and I'll delete this data set right now, and let's do the same thing using JCL. So in this case, what we're going to do now is we're going to go to our JCL library and we're going to edit a member called IEBGener. And even though we haven't discussed coding any of these particular statements, the idea here is to just kind of give you a general sense of how this works. So you can see we have a job statement, we have the execute statement, we have the DD statements. Now to just point this out very quickly, you'll notice that we reference our input data set here, and then we are creating and referencing the new data set that we want to use here. So in this case now, this work will be run as a background job. So I would submit this. You can see we have a message indicating it's been submitted. And we got a message here indicating that it is ended. So now I can go take a look at the output itself. And in this case here now, so when we look at this, we can look at the output and we can see our condition code 0 indicating successful completion. So now what we can do is we can go and take a look at the file itself. And again, I can come back here, look at the file, and now when I take a look at it, I can again see the 11 records have been copied. Now in this demonstration, we just observed how we can perform the same function using both JCL as well as our regular ISPF functions. However, very often we may find that we have jobs that require multiple input sources or data that may not be capable of being handled under TSO ISPF, in which case we have to write programs in order to be able to process that particular data. In addition, we may have multiple output results that we want to convey. And in all of these cases then, it makes real-time interaction much more difficult. And of course, when we are dealing with large volumes of data that may involve millions of data records, then it simply is impractical to imagine somebody spending hours and hours trying to put together the data or to process it. Even if they're running a program, it would conceivably lock up their user session for hours on end. So very often it's much more practical to run this as a background batch job so that it can run unattended or be scheduled as appropriate based on the requirements within data center operations themselves. The program functions, the interactions, the analysis that made it perform, these are all aspects that lend themselves well to unattended batch operations. So as an example of this, we'll take a look at our second demo, which involves running a program called RMF Redux. And in this particular case, what we're going to do is we're going to see two steps, where we are going to have input data that is being sorted, and then we're going to produce multiple reports based on the data that we have read in. And this can give you an example of the types of usage that we have in terms of being able to run background jobs and then view the resulting output. Now in the second demonstration, we have the JCL necessary in order to be able to sort the data and then run it into a program that is going to produce reports from this data. So in this particular case, you can see that we have an execute statement here indicating that we are sorting the data, and then we have another execute statement here indicating the program that we want to run to produce the reports. So in this case, based on the volume of data, this process will run for a little bit of time. But it's not going to take too long. So we can submit this. And once we submit it, you can see we have the message indicating that the job has been submitted. And then when we go and look at it and we take a look at the output, what we can do now is that we can observe that the job is still running right now. This is that job 3172. And so as we wait for it, we can see now that it's ended. So now I can see it in the output queue. And when I take a look at the detailed output here, you can see that we have all these different output files that have been created. So now I can go and I can display the various reports that have been generated by this particular program here. And you can see that the entire process here involved nothing more than us basically setting up the two steps, letting the data run into the program, and letting the program itself then produce the results that we can examine without having to be involved in the process itself. So that concludes the overview of JCL processing in general. In the subsequent modules now, we're going to take a look at how specifically we are going to code these statements and to create our own jobs and use JCL then to run the work that we need.